For today's notes, we are going to be looking at linear and nonlinear functions, and we are going to be using a table of values in order to graph them. Now, these are all functions that you've already seen in various notes or in Amplify activities, but you've never actually had to graph them yourself. They've already been graphed for you, and you just had to analyze them. Now, we're going to turn around and graph them. First, let's just look at what are the types of functions that you will be asked to graph. So these are all examples of what are called parent functions. And a parent function is just a function that is in its simplest form. Typically, it means it's going through the origin as long as the function can go through the origin. And it means that there has been no transformation. So we haven't added, subtracted, multiplied, or divided by anything. It's just its most basic. And so the parent graph is just the graph of that parent function. So the first one is a line. And this is anything that says y equals x to the first power. So this one is an example of linear. Then we have the quadratic parent function, and that's just by doing x squared. And so as soon as you have an exponent bigger than 1, it automatically becomes nonlinear. We are going to do a lot with quadratics in second semester. We also have the cubic parent function, another example of a nonlinear. We have the exponential parent function, which is where x is now in the exponent. We will do a lot with this in the third 9 weeks. So another example of nonlinear. 1 over x, the inverse parent function, you will do a lot more with that in higher level math classes. For us, we just need to identify it's nonlinear. So anytime we have a negative exponent, that's going to be nonlinear. So think about what made x go to the denominator. That would be x to the negative 1. That makes it nonlinear. Then we have the square root function, and that is also nonlinear. We did a lot with square roots at the beginning of the year. So here would be what a function with square roots would look like. And then our last one is the absolute value parent function. It is also nonlinear. And for today's notes, this is going to be the one that we're going to take a deep dive into. We are going to graph. All of our tables are going to involve absolute values. Now on homework, I'll ask you to use a table of values to graph linear, quadratic, cubic, any of those. But for notes, we're going to take a deep dive into absolute value. So absolute value functions, here is the parent function. And the parent function just, the vertex, which is also the absolute minimum, which is also another fancy way of saying the center point. It is at 0, 0. So if my vertex gets moved from 0, 0, then I have done a transformation. Okay, and if I were to take the x, what's inside of x is called the h value. What's on the outside of the absolute value symbol is called the k value. And when you put those two things together, that is where the vertex is located. Okay, and so my h value is just telling me how far I'm moving the v horizontally. And my k value is telling me how far I'm moving it vertically. Let's try this again. The vertex is at 0, 0. Vertex is the h and k together. H is how far I'm moving it horizontally. K is how far I'm moving the v vertically. And then this A value out in front is going to tell me if I'm going to make it narrower, I would multiply by like 2 or 3 or 4, and that's going to stretch it vertically. If I were to multiply by like 1/2, 1/3, 1/4, that's going to compress it vertically. That's going to make it wider. And if I multiply by a negative version, then that means it's going to be reflected over the x-axis. So when we do these after we've graphed them, we're always comparing them back to the parent function. And we are just going to explain what was the transformation. So this is a great review of vocabulary terms for Math 8, which we did a whole unit on transformations in Math 8, and so they don't go away. And here's an example where we can discuss some of those transformations. All right, so there is no number inside of the x absolute value, so I know that the center is going to be at 0, and then I'm going to pick 2 numbers to the left and 2 numbers to the right. And now I'm just plugging them in for x. So the absolute value of -2 is 2. And then 2 plus 1 is 3. And then the absolute value of -1 is 1. And 1 plus 1 is 2. And the absolute value of 0 is 0. And 0 plus 1 is 1. And the absolute value of 1 is 1. And 1 plus 1 is 2. And the absolute value of 2 is 2, and 2 plus 1 is 3. So I can now go plot these points. I can put a dot at -2, +3. I can put a dot at -1, +2. I can put a dot at 0, 1. I can put a dot at 1, 2. I can put a dot at 2, 3. And I can see that this new function has been translated up 1 unit. And from the equation, I knew that because this +1 on the outside tells me how far it moved vertically. So the transformation was that it was translated vertically up, because it was positive, 1 unit. And my new vertex is now sitting right here. That's my center point at 0, 1. Okay, let's look at the next one. So what I think should happen, I don't see anything on the outside, no plus or minuses, so I don't think it's going to go up or down. I do see a negative out here, so I think it's going to get reflected over the x-axis. And then there is a number in here, this -2, and so I know that I need to make the center of my table be 2. I need to go 2 to the left and 2 to the right, okay? And so now I'm going to use that to find where the vertex is. And the formula is built off of a minus sign. So this is telling me that I think it's going to be translated right 2 units. So for it to stay -2 means I plugged a -2. It means I plugged in a +2. These are just my thoughts. Now I'm going to go graph it and see what happened. So 0 minus 2 is -2. The absolute value of -2 is 2. -1 times 2 is -2. 1 minus 2 is -1. The absolute value of -1 is 1. -1 times 1 is -1. 2 minus 2 is 0. -1 times 0 is 0. 3 minus 2 is 1. The absolute value of 1 is 1. -1 times 1 is -1. And then 4 minus 2 is 2. The absolute value of 2 is 2. -1 times 2 is -2. Okay, so now I'm going to go plot these points. I have a point at 0, -2. I have a point at 1, -1. 2, 0. 3, -1. 4, 2. So my idea that it got translated to the right 2 held up, and my idea that it was reflected across the x-axis is also holding up. So now I have my new vertex is right there at 2, 0. And to describe the transformation, it's going to have 2 descriptions. First, it was translated horizontally right 2 units. And then that negative A value also told me that it was reflected over the x-axis. And so this is going to be a very, very, very useful formula to make sure you know and you have what each part is controlling. It will save you some time and effort. And you are going to see a lot of this coming back in the second semester as we do other nonlinear functions. But that's the end of today's notes.